Right. So this is going to be your heading, converting decimal values. It's better you, yeah, doesn't matter. Converting a decimal value, I'm sorry, converting a decimal value into a non-decimal value. Right. So as I mentioned you last week, this is about division and multiplication. In here in the conversions, you can find several different divisions as well as multiplications. So the very first example that I'm going to take is, I'm going to take a very simple example, right? So this is going to be my first example. Example number 1. Right, so what I'm trying to do is converting 47, this is a decimal value, into binary. Right? So our task is converting the value 47, which is in decimal, into a binary value. Right. So what is the way that we can accomplish this? It's a very simple scenario that we have, people, right? Since we are converting a decimal value, now this is important. Now, when you are given a conversion, first of all, you have to figure out what kind of a value, or like in a value in which base are going to be converted into which particular base. Convert කරන්න ගන්නේ මොන base එකේ කෙනෙක්ද? එයාව convert වෙන්නේ මොන කෙනා බවටද? Right? So here, what I'm teaching you is specifically talking about decimal values, right? So here we are trying to learn how a decimal value is converted into a binary, into an octal, into an hexadecimal, right? 3 different number systems. This is the decimal number system. These are the things I have referred as the non-decimal ones, right? So in this example, we are talking about converting a decimal value into a binary value. When we are doing this, the first thing that we have to do is we have to take the decimal value and we are going to divide it by 2. And why we are dividing it by 2? We are converting this value into a binary value. Right? So how we are going to divide this thing? Right? The I think the division that you have done is a little bit different from this division.
Sir, 2 times 2, 4, 2 times 3, 6, remainder 1, sir.
That's right. So like, first of all, you have to figure out how many times of 2 are there for the 4. So you have to say 2 times 2 is 4. And not 0 is remaining from that. Right? And for 7, it's 2 times 3. Right? And 2 times 3 is 6. Here we are dealing with the 7. So remaining part, we should address it by putting a hyphen or a dash, and we have to write it at your right, the remaining part. Right? So when you are doing the division properly, you have to say, Suhara, teaching, don't disturb me. Okay, I'll come and see after my class also. Right, so it is 23 and 1 is remaining. Now, this is not finished, right? So we have to do this division until we get something less than 2, right? Maybe in the in your school, teacher will tell you some another way. I'll show you that way as well. But what I'm telling you is the easiest and the shortest way of doing this. So now we have taken 23 as the answer. 23 is not less than 2. So we are going to divide it by 2 again. Right? So for 2, there are 2 times 1. And for 3, again, there are 2 times 1. And 1 is remaining. And 11 as our answer is not. It is not less than 2. So we are dividing by 2 again. So 0 times are there for 1. And with this one and the other one performs 11. So there will be 5 times of 2 for 11. And again, 1 is remaining. Still 5 is not something less than 2. Suhara, can you go to that table? Go to the pink bucket table and do the play. Then you can play as you can, Susu. Right? Right. So the 5 is not less than 2. So we are going to divide it by 2 again. So there are 2 times of 2 for 5. That means 4, and 1 is remaining again. And when it comes to the 2, this answer, still it is not less than 2. So we are going to divide it by again. Right, by 2. So we got 1 time of 2. And don't forget to write the remainder. Even though we have nothing as the remainder, we must write, we must indicate it using a 0. Are you getting this, people? Everyone, are you getting this up to the point? Okay. So now we stop the division, right? Why we are stopping this? It is because we have received something less than 2 over here, right? So we stop it. Then what we are going to do is we start from the place that we have stopped, and we consider the remainders with that from bottom to top, right? So that is something very, very important for you to remember. We start from the place we have stopped, and then we consider the remainders from bottom to top. Right? So then we can write the answer as 1, 0, 1, 1, 1, and 1. Okay, if I recap the things that we have done was like we convert a decimal value, which is this, into a binary value. So when we are doing the conversion, we wrote the binary value and we divide it by 2. The reason for you to divide it by 2, it is because we are converting the decimal into a binary. So then we received an answer by dividing by 2, but it is not, since it is not less than 2, we have done the division again and again until we receive something less than 2. So once we receive something less than 2, we stop the division. We start from the place where we have stopped, or like from the last answer that we received, and plus that answer plus the remainders will be written from bottom to top. Right? So that gives us this answer. Okay, people, is that clear?
Yes, sir.
Right, great. So let's write the example, people.
Big ones. Gather around. We are all teams. Our sisters.
I think you have written the heading. So here comes the first example. Let's write it on your book.
Sisters are gathered around. Great. I'm dead. You're other sisters. Transformation. You are super sweet.
Okay, one is done. How about others?
Done, sir.
Okay.
Sir,
Yes, yes, on.
only this, no, sir?
Yeah, only this, only this.
Okay, sir. It is. I asked because sir, I was a little late. That's why, sir.
Never mind, never mind, never mind, Rizwan. It was just this. Have you written the heading, Rizwan?
Decimal number system, sir.
No, it's something like this. Hold on.
They all transform. Perfect. Get done, lion, Caesar.
Converting the decimal value into a non-decimal value.
Oh, if I'm standard properly. Oh, get him, Caesar. I'll leave you. You're sucking his bloody food. I think now, they now will make him to promise. Wow, one big powerful handle.
Okay, are we done? Can we move forward?
Yes, sir.
Right, great. So the second example that I'm going to do is with you. I'm going to convert a decimal value into an octal. Right, so the example number 2. Suhara, lower the sound, please. So example number 2. What I'm going to do is like convert. Let's think about 123 in decimal into octal. right? So the task is 123, a decimal value, needs to be converted into an octal equivalent. Now, since you know the method of converting a decimal into binary, same technique can be applied to this particular one as well. So what are we going to do is we are going to take 123, since it is the one that we need to convert, and we are going to divide this by 1. Yes? Yeah, when we are converting it into a binary, we divide it by 2. Now we are going to divide it by 8. Why we are divided by 8? Because we are converting this into an octal value. Right? I think now you are getting the pattern. Right? So the decimal value is there. When it is converted into binary, it divides by 2. And when a decimal is converted into an octal, it is divided by 8. So how 123 is going to be divided by 8? For 12, how many times of 8 are there?
1.
Yes.
1.
Yes, and the remaining is 4. And that 4 and this 3 creates what?
5.
43. 43, yes, for 43, there are 5 times of 8. And how much you got as the remainder?
3.
It's
3.
3. Very good. So again, the same technique. We are going to divide this until when? Until we are finding something less than 8. In the previous conversion, we divided until we found something less than 2, because we were dividing by 2. Here we are dividing by 8, so we are dividing the answer until we found something less than 8. So like when we are dividing 15 with 8, so it's just 1, and 7 will be the remaining amount. So now we have found something less than 8. So with that, plus the remainders from top to bottom, we are going to write the answer. So the answer is going to be 173 in octals. Is that clear, everyone?
Yes, sir.
Okay, so I'll recap it again. We were talking about converting this value into an octal. So we took that value, we divided by 8. The reason for dividing by 8, because we were converting this value into an octal. So we must do the dividing process until we found something less than 8. So once we found something less than 8, answer can be written starting from the last answer plus the remainders, moving from bottom to top. Okay, so here comes your second example. You can copy it down now. All right, 2 are done. How about others?
Done, sir.
Okay, anyone who is still writing? Okay, so we can move to the third example, which we are going to see how a decimal will be converted into a hexadecimal, right? So let's take that into consideration. So as the third example, I'm going to take this. So my third example, this is example number 3.
Sir,
Yes, Rizwan.
sir, today I'm having a connection problem, sir. So again,
Yeah.
I reconnected using the phone. Sir, can you show me the before sum, sir?
Hold on,
I
hold on,
couldn't
hold on.
write it.
Yeah, hold on, Rizwan, hold on. Okay, you can go with this. Copy it down, Rizwan, copy it quickly. So meanwhile, I'll write the question at the below.
Done, sir.
Okay, right, okay. Okay, let me think something easy for you in here. I'll take it like this. Right, convert 174 in decimal into hexadecimal. Right. So our task is converting 174, the decimal value, into a hexadecimal. Which means base in 16. So now we know the pattern, right? So help me out, people. I take 174.
Sir, 16. Yes, sir. 16 times 116.
That's right. It will be
And
divided by 16. Why it is divided by 16? Because we are converting it
Oh.
into a hexadecimal. Right? So for 17, how many 16s are there? Just one, right?
1, sir, 1.
Just one. And for 14, there
Zero,
are
sir.
no 16.
0.
Yes, so it's
0.
0. How much you get as a remainder? 14 will be remaining. Is it with paper?
Yes.
Yeah, so like for 174, there are 10 times of 16, which gives you 160, and 14 is remaining. Now, the problem is, be very careful when you are receiving the values which is larger than 9 in hexadecimal number system. Because in hexadecimal number system, they don't have some things like 10, 11, 12, 13, 14, and 15. Instead of that, what do they have? For 10, they use capital
A, B,
Yes.
A, B,
For
C, D.
11, yes, it use B. For 12, it use C, likewise. And for D, I'm sorry, for 13, they use D. Right, so for 14, they use E. For 15, they use F. Right, so be very careful when you are receiving something like this. So since we are receiving 10, we are not going to write 10. Instead of that, we are going to write A. And since we are receiving 14 as the remainder, we are not going to write 14. Instead of that, we are going to write E. So when it comes to the answer, have we received something less than 16? We have,
No,
right?
sir.
We have, because 10 is something less than 16, right? So since it is less than 16, we are going to stop our division. So what is going to be the answer? This is going to be your answer. With that, the answer that you receive very lastly, and then we are going to write it with the remaining part from bottom to top. So the final answer is going to be A, E in hexadecimal. People, is that clear?
Yes, sir.
Okay. So let me recap it again. So we take 174, it is a decimal which will be converted into a hexadecimal. So we take the 174, we divide it by 16. The reason is we are converting it to a hexadecimal value. So we must divide a number by 16 until we receive something less than 16. So at the very first division, we receive 10 as the answer and 14 as the remainder. So that means we can stop our division because the answer is less than 16, but we don't represent 10 and 14 as it is in hexadecimal. For 10, we use capital A. For 14, we use capital E. So because of that, we write the answer as AE in hexadecimal. All right. So if you got any problem with any of these conversion, now it's a time for you to ask the question. And meanwhile, you can copy this down as well. Right, and you really don't need to round up these things, people. I'm just rounding it up just for the elaborations. You can keep it like this. So it is that easy, people.
But Mimi's grandmother is a little bit weak today. She's a little bit sick. Mimi's grandmother. Mimi's grandmother. I told Mimi to give her medicine and even biscuits.
All right.
Even milk.
One is done. How about others?
Even some milk. Even some healthy milk.
Okay.
That helped Mimi's grandmother feel good.
All right. Great. Anyone who is still writing?
Vinny's grandmother will be so happy. Then I have an idea. Hold on, Dad. I'm making something.
All right. So now we can go for some questions. So I will throw you some questions. It's your time to do the calculation and send me the answers. Yes, Sanushi, definitely. If it is 10 in hexadecimal, it must be represented from A. If it is 14 in hexadecimal, it must be represented from E. Right? Okay, so here comes the questions. Let me do the question on a new page.
Daddy.
Yes, Susu.
Can you have this paper?
Wait, Susu. I'm going to hold on. Let me see the paper.
Is it good?
That's okay. All right. Now the questions are, convert the following into
This is for this.
binary
That to your father. Say that to your grandma.
octal and hexadecimal.
So can you give this to me?
Well,
I'm going to see you in a little
Right.
20 seconds.
so here comes the question. So it's what you need to convert is 69, which is a decimal, as a second one,
Good for your grandma. She will love it.
420
So Hannah made that for her.
decimal,
So Hannah made that for her grandmother.
and 731.
So Hannah is sure
decimal.
chef.
Yeah,
Great job.
so you have to convert each and every value
Hello, wait.
to a binary, to its octal, and to its hexadecimal. So 3 conversions regarding a one particular question. So do it slowly, right? You can take your time, right? Do it slowly, and you can send me the values as a chat message, so I can go through whether those are correct or wrong. People, when you are doing the workings, do it clearly and nicely, people. Don't do it as a rough work, right? Because when you are going through it again, you will see, like you will see it clearly how the things have done, right? So if you got any questions regarding this still, you can ask.
Excuse me, sir.
Yes, it's on.
Sir, did you say to do this, sir? I reconnected, sir.
Rizwan, I'm not getting you clearly.
Sir, I reconnected. Sir, did you say to do this to us?
Yes. I asked you to do this, like each and every value must be converted into all 3 number systems, like to binary, to octal, as well as to hexadecimal.
Just sound like Granny Smith's voice. Yeah, we do. Hey, that's what. This is Granny Smith. It's howdy do. Granny Smith, are you very sick? Sure I am. You must give this to me. Why? Because I'll get sick again. Let's see now. You hungry? Hey, you darling. You're welcome, Granny Smith. Yes, my name is Granny Smith. Ooh, this feels much better. Everyone, all taste it. It's my daughter and granddaughter. Tiger lady. Willie's a tiger. This looks delicious, Granny Smith. Thanks. You go next. Yeah. Granny Smith is also very. Yeah.
Okay, people, if you are done, you can send me the answers through the chat, or otherwise you can send me the answers through a WhatsApp message. Doesn't matter. All right. So let me have the answers from all of you. So it will be easier for me to evaluate. All right. Yes, Utkarsha. Let me check the answers. So the first one, yes, that's correct. That is correct. Second answer, okay. Yes, very good. Third answer, yes. Yes, very well done. Very well done. Utkarsha, very good. All are correct. Utkarsha, I guess. Utkarsha, very good. All are correct.
Yes, you're feeling way too tight. Yes. Try pulling it out. That was close. Whoa, that was too tight.
All right, so I'm going to do the very first math over here.
My tail is too tight.
Right, I hope every one of you have done it and moving to the second one, so you can check whether what you have done is correct or wrong. Right, so I'm dividing 69 by 2. So it's going to be 34 and 1 is remaining. Again by 2, 17, 0 is remaining. Again by 2, 8, and 1 is remaining. Again by 2, 4 and
The
0.
answer is 1 0 0 1 triple 0 and double 1 and 2. It's
Okay, this one is good.
it is
Yes, and if I write the answer, it's going to be 1 triple 0 and 1 0 1. Right, so this is going to be the answer for the 69 in binary. How about the 69 in octal? So we have to do it by 8. So there will be 8 8s for 69. It is 64 and 5 is remaining. And if I divide it by 8 again, 1 and 0 is remaining. So the answer is going to be 105 in octal. Right, and when it comes to the hexadecimals, 69 divided by 16, it has 4 16s, that means 64 and 5 is remaining, and that's all what you have to do. So like the answer is going to be 45 in hexadecimal. Simple as that. Right? So yeah, check whether you are like what you have done is okay. Right? Yes, Rizwan. Your answers are correct. Sanushi. Yes, I think the first one, yes, it is correct. The second one, let me see. Yeah, that is correct too. Very good. The third one, yes, yes. That's very good. Very good, Sanushi. All are correct. All are correct. Right, so I'm going to do 420 over here. Just check whether you got that correct as well. So let's go with 420. So 420 by 2, it's going to be 210.
1 1
5 0 is remaining. Then 52 1 is remaining. Then 26 0 is remaining. Then by 2 13 0 is remaining. Here 2 6 is 1 is remaining. Here we can take 3 0 is remaining. 2 it is 1 is the answer and 1 is remaining. So you can take the answer from bottom to the top. So the answer is going to be 1 1 0 1 0 0 and 1 0 0 in binary. Right, so if I do the 420 in binary, I'm sorry, in octal, so it's going to be 5 8s. Over here it's 40 and 20 is remaining. For 20, it's 2 times of 8 and 4 is remaining. And so divide 52 by 8 again, so it's going to be a 6 and 4 is remaining. So the answer is going to be 644 in octal.
is it 6,427 or 604?
Come again, Rizwan. 6,000.
6,227. Is it wrong, sir?
6,220. Yeah, it should be. Just see whether Rizwan, See where you have missed the thing, Rizwan, because once 120 is divided by 8, it's going to give you 52. Are you clear with that?
Yes, sir, it is clear.
Yeah, so 52 is divided by 8, so it's going to be 6 and 4 is remaining. Right, so 420, I'm going to divide it by 16. So there will be 2 16s, which is 32. 10 is remaining. For 100, there will be 6 16s, which give you 96, I guess. Yes, 96, and 4 is remaining. And again, 26 need to be divided by 16, so it will give 1. And 10 is remaining. We don't write 10. Instead of 10, we represent it using 8. So our answers are going to be 1A4 as the hexadecimal answer. Right? So 1A4 in hexadecimal. There you go. People, just give me a second. All right, so those are the answers for the second one. And let's do the third one somewhere around here.
Miss, excuse me, sir.
Yes, Buddha.
Can I get the answer for the for the first question, octal and hexadecimal one, sir?
Yeah, these are the octal and hexadecimals. 105 in octal, 45 in hexadecimal. Okay, this on.
Yes, sir, that is okay, sir. Can I get the octal one, sir?
Octal means like.
Yes, sir, this okay. Okay, sir, those are correct, sir. Thank you, sir.
Right away. So we are going to do the 731 calculation over here. So yes, use the black. So 731 will be big value. We are going to do it by 2. So it's going to be 3 and it is 6. For 13, it's going to be 6, 12, and for 11, it's going to be 5, and 1 is remaining. And we are doing it again by 2. 1, this is going to be 8, and this is going to be 2, and 1 is remaining. And we are doing it by 2 again, 91, and 0 is remaining. Doing it by 2 again, 45, 1 is remaining. Doing it by 2 again, 22, 1 is remaining. Divided by 2, 11, 0 is remaining. Divided by 2, 5 and 1 is remaining. Divided by 2 again, 2 and 1 is remaining. And finally, 1 and 0 is remaining. It's quite lengthy, but we can have it like this. So the answer is going to be So it is 1 0 1 1 0 1 1 0 1 1. Right. So that is going to be your answer. Yes. In binary. So 731, I'm doing the octal part right over here. So for 73, there are 9 times of 8, which is 72, 1 is remaining. For 11, there is 1 and 3 is remaining. For 91, there is 1 time of 8, and for 11 is 1 and 3 is remaining again. So yeah, we can go for this. We can divide the 11 by 8 again, and we can say 1 and 3 is remaining. So the final answer is going to be 1333 in octal. Right, and 731 in hexadecimal. There are 4 times of 16, which is 64, and 15 is remaining, right? I'm sorry, it's not 15, it's 9 is remaining. For 91, there are 5 times of 16, which is 80, and 11 is remaining. So the 11 is going to be here. And for 45, if we are divided by 16, there are 2 times of 16, 32, and 13 is remaining. So as you know, for 13, we are going to indicate the 13 as D. We are going to indicate the 11 as B. So our answers are going to be 11 dB. I'm sorry, 2 dB, 2 dB, 2 D and B in hexadecimal. Okay, so that's going to be the values for the third answer that we have done. Okay, the people who have sent me the answers, you got a lot of things in a very correct manner. Most of you have sent me the answers, got every answer correct. It's very good people, right? So yeah, any questions regarding this paper? Any place where you are not okay with? If not, we can move to the next conversion. Hi there. All right, so we are moving to the next conversion type. Right. So the next conversion type, the second type, the task that we have to do, the conversion that we have to do is converting non-decimal values into decimal values.
Points for this, rows for this.
Right. So yeah, sorry with my yes. Okay, so here again we are trying to convert a binary, an octal, and hexadecimal values into what? Into a decimal value, kind of the reverse of the previous conversion. Right, so let's see how we are going to do this. It is again, oh, I'm sorry. Right, so it is again a simple technique that you are going to go through, but it's better you listen carefully to understand how this is done. So the first example that I'm going to take, example number 1. I'm asking you to convert this value, right? So convert 10110, which is in binary, into decimal. Right, so our task is converting 10110 into a decimal value. So in this case, we are going to consider the place value of these symbols. Now, what do we mean by the place values? Now, you can remember the abacus that you have learned in early days, right? In your childhood. Right, so there had ones, there were tens, there were hundreds, and the next one is going to be thousands, right? So if someone asks you to represent 435, you were very keen at this, right? You were putting 5 balls over here and drawing 3 balls over here and drawing 4 balls over here. All right, so we just blindly did it as the not that it's not good to say blindly, as the way that our teacher taught us, we feel these things. So in those days, we were talking about these decimal values, people. These decimal values. 435 is a decimal value. Now, look at this relationship. 1 can be represented as 10 to the power 0. 10 can be represented as 10 to the power 1. 100 can be represented as 10 to the power 2. Right? And what is the number system that we are referring here? It's the decimal number system. So since we are referring to decimal number system, we are getting the place values, these are called the place values, as 10 to the powers. Now, with that knowledge, can anyone tell me how comes what should be the place values of the binary number system in which to the powers that we are going to receive? Yes, it is 2 to the powers.
2 to the power.
Yes, so this is going to be 2 to the power 0. This is going to be 2 to the power 1. This is going to be 2 to the power 2. This is going to be 2 to the power 3. This is going to be 2 to the power 4. Right? So now what I can do is, yes, Sandrashi, what I can do is I can convert these 2 to the powers into their values, right? Which means I'm not going to represent this as a 2 to the power. I'm going to represent it like this. We display things on the abacus. So what are the values that I'm going to receive? 2 to the power 0 means for any number, power 0 represents 1. 2 to the power represents 2. 2 to the power 2 represents 4. 2 to the power 3 represents 8. 2 to the power 4 represents 16.
sis.
right?
You sis. You sis.
Now
Yeah. Want some you sis.
we got a very small thing to do. We consider the place value and we consider the corresponding symbol value. And we are going to multiply these two together. That means here it will create 16 into 1. Right? We are going to do the same to the other places as well. So 8 will give me 8 into 0 because its place value is, its symbol value is 0. The place value 4 is going to give me a multiplication with 1. So that means 4 into 1. Place value 2 is going to give me a multiplication with 1 again. So 2 into 1. Place value 1 is going to give me a multiplication with 0. So that means 1 into 0. And multiplication is not the only thing that we are going to do. Once we get the values of the multiplication, we are going to add these things up. That means I'm going to add 16 plus 0 plus 4 plus 2 plus 0 again, which will give me the answer as 22, which is in decimal number system. People, is that clear?
Yes, sir.
Yes, sir.
Okay, great. So this is how we are going to convert a binary number into a decimal number. So let me ask you a question. If we need to convert an octal value into a decimal number system, what should be our place values, in which to the powers our place values are going to be? Yes, very good. So if it is an octal number, which we are going to convert into the decimal, the place values are going to come as 8 to the powers. If it is a hexadecimal, those will be taken as 16 to the powers. Right? Okay, so you can write this down as the, you can have the heading, then you have the very first example. Go with it, people.
So should we write draw the abacus?
Oh no, you don't need to do it. It is just an illustration. You don't need this thing to be drawn.
Okay.
Now I got to the big one. You did. Now I got in the big one.
People, let me know when you are done.
Answer.
Okay, one is done. How about others?
Done, sir.
Answer.
All right. So I'm going to the second example now. Right. In the second example, I'm going to show you how to convert an octal number into a decimal. Right. So let me take the second example. Yeah, some communication error happens, people. Can you hear me clearly?
Excuse me, sir.
Yeah, can you hear me clearly, people?
How can you hear? Sir.
Yeah. I'm getting little disturbances, people.
I think
Yeah. People, am I clear at your place? People, am I clear at your place?
yes, sir.
Right, okay. Yeah, since we have started a little late, can you stay another 5 to 10 minutes with me so we can finish up this conversion and go?
Okay, of course, sir.
Excuse me, sir.
Yes, sir.
Sir, I have a class now at 5.
All right, okay. So, Dua, can you refer the final 2 theories from the recording, Dua?
Okay, sir. I will stay till the other class starts and I will leave then.
That's good. That's good. That's good. I'll do this as soon as possible. Right? Okay. So the next conversion that I'm going to show you. Now, I hold on a second. Yeah, sorry for that, people. My other class is happening online today as well. So some people are here because they didn't get the idea. Okay, so my second example, example number 2. Yeah, my requirement is like what I'm going to do is converting, like let's say convert. Let's take something easy for you to convert. 537
Students.
in octal
No, there's zero.
into decimal,
I'll show you one.
right?
Good.
Right, so here, as we discussed, 537, we are taking the place value as what? 8 to the power 0, 8 to the power 1, and 8 to the power 2. Right, so that means this is 1, this is 8, and this is 64. You are not going to go beyond these people because like 8 to the power 3 is something a little bit bigger, which is 512. So for your knowledge, just remember 4 places of 8 to the powers 1, 8, 64, and 512. That will be the maximum that you are going to get. Right? So you are going to do the same thing. You take the place value, you multiply it with the symbol value. Right? So what we are going to do is like 5 into 64 plus, I'll write it the other way around to be much clearer. We're going to take
Dad, are the Aki's
64
coming over there?
into 5
Daddy,
plus,
are the Aki's coming there?
no, Suzu, they are not going to come today. 8 into 3 plus 1 into 7. So that means 64 into 5 equals 320 plus 8 into 3 equals 24 plus 1 into 7 equals 7, which gives you how much? 320 into 24, 344, 344 plus 7, 351. 351 in decimal. People, is that clear?
Yes, sir.
Right, that's great. So you can copy this as the second example.
Okay, sir.
Right, so do it as quickly as possible so we can go for the third one.
Done, sir.
Done, sir.
Right, okay, so we'll move to the third one.
Done, sir.
All right. Yeah, here comes the third example. So the third example, example number 3. Let's take convert. Here we are going to convert a hexadecimal value into a decimal. Let's take, ABC. Right. Let's make it a little bit, okay. Like A5C, let's say. Hexadecimal into a decimal. Right, so here we take A5C and we have to be very careful. A means 10. C means what? It is 12. So the place values 16 to the power 0, 16 to the power 1, 16 to the power 2. Right, so that means this is 1, this is 16, this is 256. So we are going to go on the same road. We take the place value, we are going to multiply it with the symbol value. So that means
Excuse me, sir.
Yes, Dua.
Sir, are you going to stop from here?
Yes, Dua. I'm going to stop from here. Just write in this and go. We are going to leave.
Okay, sir.
256 into 10 plus 16 into 5 plus 1 into 12. So which will give you 2560 plus 80 plus 12. That means 3652. 3652 in decimal. It's not 3000, it's 2652. My bad. It should be 2652. Is that correct? Yes. So this is going to be the very last conversion that we are going to do. Is that clear, everyone?
Yes, sir.
Yes, sir, please.
Right, great. So you can copy this down, then we can end our session. Right, so I will be here until you copy this down, everyone, once everyone is leave. So thank you very much, everyone. You can copy this down and leave the session. Right, I'll see you on next week for the very same time. Right, thank you very much, everyone. Have a very nice day.
Thank you, sir. My class started. I'm going to leave.
Okay, Dua, no worries. Thank you.
Sir, thank you, sir, for today's class. There was an
Right, okay, Rison. Thank you very much.
Thank you, sir.
Thank you, sir.
Right, everyone. Thank you very much.
Goodbye, sir.
Right, okay, goodbye. Thank you.